Let's look at some trickier quadratic equations. You get x cubed equals 9x. It is so tempting to divide both sides by x, but don't do it. Gather everything over to one side and set it equal to 0. Then I want you to factor out an x, because you always look for a GCF first. Then you want to keep going. Can you keep factoring? And yes, you should recognize this is a dots. And so I set each of these factors equal to 0, because if I think about my product, zero product principle, the only way that these three factors will produce 0 is if A is equal to 0, or B is equal to 0, or if C would equal 0. They don't all have to equal 0 at the same time. Just one of them has to be, and then I would get the 0 over here. So my solutions are 0, -3, and 3. If you had done the dangerous error of dividing by an x, divide x, you would have gotten x squared equals 9. And then hopefully you would have set everything equal to 0 and gotten dots. And you would have gotten some of the solutions, but you would be missing one. So you would have divided by a variable, and actually one of the solutions was 0. So by dividing by a variable, first of all, you might have divided by 0. And second of all, look, your answer's wrong. You lost a solution. That's called losing a solution. Let's look at this one and approach it two different ways. First, I want to divide both sides by 5. Wait, you just said don't divide by a variable. I know. 5's not a variable. Okay, now I'm going to set everything equal to 0. I see this is a dots. So my solution is a -1 and a 1. Cool. Let's say I didn't divide both sides by 5 because it made me nervous. And so I subtracted 5. I got everything to the side. I then look at this and notice I have a GCF. I then notice I can keep factoring. My solution is, well, 5 doesn't give me a solution. Be careful. This does not give you a solution. And no, the solution is not 5. It just doesn't give you anything. For example, you could conceivably just divide everything by 5 here, and then you would get something very similar. So again, no matter which way you do this, you get the same solution of -1 and 1. Let's look at this tricky one. Ugh. Well, let's just move forward. Let's combine like terms and get everything set equal to 0. So -6x squared. All right, now let's add 3x to both sides to get 13x. Now we have to subtract 8. All right. Cool, so everything's set equal to 0. I'm looking for a GCF. No dice. I'm going to look at my coefficient here. I really don't like that there's a negative, so I'm going to divide through by -1. Or another way to think of that is I'm going to multiply everything, both sides, by a -1. And yeah, I'm allowed to do that because I can multiply both sides by whatever I want. So I'll now have a -13x and a -5. Okay, so now I'm looking at this. At least I have a positive coefficient. There's no GCF. Ugh, I have to do product sum technique. That's okay. I can handle that. So I look at my 6 and my -5, and that's my product of -30. My sum is -13. So what factors of -30 will give me 13? I really wanted -10 and -3, but that would not have multiplied to give me -30. So I guess I'll have to opt for -15 and 2, because those add up to give me -13. So now I'm going to rewrite my -13x using a -15x plus a 2x. Now I pair these up. I take a common factor out of here. And I'm hoping to also see 2x minus 5 over here. And that's exactly what I have, so I guess this factor just has to be 1. That's a little tricky, but that's okay. Now I'm going to take a GCF out, and that's 2x minus 5, and what is left over is my 3x plus 1. So now I have this factored. By the way, look how far we've come. Whew, okay. Now I have this factored. I'm going to set each of these equal to 0. So 2x minus 5 equals 0. I'm going to add 5. 2x is going to be 5, and so x is 5 halves. Maybe you can do this one in your head, and you will get x equals negative 1/3. So my solution is negative 1/3 and 5 halves. Again, you should go back. Ugh, I know, but you should go back and substitute these, both those quantities and or values. Okay, you should go back. I know it's rough, and substitute these values in and make sure this equation works out. So what would that look like? Well, you take negative 1/3. Whoops. So that'd be a 9th once I square it, plus 10 times a negative 1/3 plus 13 equals 8 plus 9 times a 9th minus 3 times negative 1/3. See, it seemed pretty awful, but come on, it's not that bad, because look, these cancel, that's plus 1. These cancel, that's plus 1. Okay, this side just ended up being 10. Come on, there are worse things. This will cancel. I'll have a 1/3 plus a negative 10/3 plus 13. So I'll have a negative 9/3 plus 13. So that's really a negative 3 plus 13. Does that give me 10? Yes. Cool. So notice, this looks awful, and even the solutions were fractional, so we got worried, but it wasn't that hard to check. So yes, then I would want to put in 5 halves and check to make sure that works, but I won't put you through that pain.